Today we're solving problem 13 and 14 from the Fall Amc 10B of 2021. Okay, 13. A square with side length 3 is inscribed in an isosceles triangle with one side of the square along the base of the triangle. A square with side length 2 has 2 vertices on the other square and the other two on sides of the triangle as shown. What is the area of the triangle? So this is basically what they put in the test, basically the drawing here. Now we are given, this is an isosceles triangle, okay, and it also states that we have 2 squares here. This one, the larger one, has a side length of 3, and the smaller one has a side length of 2. And we want to find the area of this whole triangle. Well, now the only challenging part is finding this this triangle here, but let's just start with what we know. Well, this is an isosceles triangle. It's isosceles, meaning these 2 sides are the same, so therefore we can basically cut it in half and these 2 sides will be equal. So, using that logic, this side length is 2 and this is 3. This is part of the 3. That means the other 2 parts have to add up to 1. When you divide that by 2, these 2 have to be 0.5 and then 0.5. Okay. Well, we know all the area of this. That's cool. So this sort of trapezoid shape, the smaller trapezoid is the square. 2 times 2 is 4, plus the area of the 2 of these triangles, and they're congruent. So this is just 2 times 0.5 or 1. This is 5. That's the area of that trapezoid. Now we want to find, right now we're going to focus on the area of this bigger trapezoid. Well, we can find a common ratio. The common ratio for this right triangle, I guess, is 2 to 0.5. Well, that ratio, 2 divided by 0.5, I want to use fractions because that's what the answer's in. This is going to be 4. So using that same logic, this side length, which is 3 divided by some side length, something, let's just call it x, has to equal 4 because it's a common ratio. Therefore, x is 3/4. And I let x be this side, so this is 3/4 by using a common ratio. Well, now, earlier we also stated that these 2 triangles are also congruent. And the reason we can use this common ratio is because all these triangles are similar. Okay? Now, the area of this trapezoid is 9 plus 3 times 3/4, 9/4. Okay? This is going to be 36. This is going to be over 4. 36. 45 over 4. I'll do it in fractions first. Okay. Let's just do it like this. Oh, this is going to be 11 and 1/4. Okay. Well, let's just sum these 2 trapezoids up. 11 and 1/4 plus 5. Well, this is equal to 16 and 1/4. That's not our answer because we just found the area of these 2 trapezoids sum. We still want to find this basically small triangle. Well, we know that this is a square, so this has to be 2. When we cut it down from the middle, we see that we can split it into like 2 congruent triangles. And let's call the height, I don't know, A. So, and let's just call the entire area of the triangle of this sector Y. So, let's just do this. Well, according to the triangle formula, 2A over 2 equals Y. So A is equal to Y. That means that if we just find the height of this triangle, and add that here, we'll just be done. Well, we found this common ratio earlier, but it's not due to 2. We split this into 2 congruent triangles for a reason. so we can make one 1 and the other one 1. Okay, now let the height be A. The ratio of the height to the side length or the base is 1. And earlier, these are also similar triangles because they have the same angle measure. All 3 of these triangles. And this is equal to 4. So therefore, the side length is 4. We already stated that the sum of these two trapezoids is 16 and 1/4. 16 and 1/4 plus 4 will give us our answer, or 20 and 1/4. So we are done.